So the last thing we're going to look at this week is 2.1, okay, and we'll look at part of 2.2 a little bit, not too much. But in 2.1, they're going to talk about what are called zeros of polynomial functions. You might also hear me use the word root. Root and zero, they mean the same thing. Basically, what a zero of a polynomial is it's where it crosses the x-axis. That's how you can think of it visually. Let's graph that, and let's see where it crosses the x-axis. Okay, so I'm going to type in 2x cubed. I'm going to type in minus 3x squared, minus 3x, and plus 2. All right, I'm going to do zoom 6. I think zoom 6 is going to work for most problems in this section. Okay. How many times does that graph cross the x-axis?
3.
Yep, 3 times. Okay, so it crosses 3 times. Now, what I want to think about is if you could find the coordinates of the first place where it crosses, the second place, and the third place, what would the y value be for each one of those coordinates since they're on the x-axis? Yep. 0, yeah. So the y coordinate of all those points would be 0. So what I want to do now is I want to graph something else. I want to leave what I already have there. But in y2, let's go ahead and type in what we see on the board. Let's type in parentheses, x plus 1, 2x minus 1, and x minus 2. Okay, so I want to hit graph, and I want you to watch what happens between the blue graph and the red graph on the screen. There's the blue one, it's still there. Watch the red one. How do the blue one and the red one compare to each other?
They're identical.
Yeah, they are. They're the same thing. So somehow you can take what we have right here and you can turn it into what's down here. The goal today is not to learn how to do that. Okay? I just, for now, want you to understand that what I have there and what was up above are exactly the same thing. When you write something with different sets of parentheses, the process to do that begins with an F. Does anybody remember what that's called? A lot of times you do it with 2 sets of parentheses, with like a quadratic. And this is one way you can solve a quadratic. Yeah?
Factoring?
Factoring. So what I have here, this is the factored form of what I have underlined up above. Okay, so somehow you can get that factored form. I want to take each one of those factors. I want to take the x plus 1, the 2x minus 1, and the x minus 2. And I want to set each one of them equal to 0. And watch what happens. So you've taken what looked like kind of a complicated problem, and you've really broken it down into 3 smaller problems by having it factored. If I solve this first one for x, what would I get once x is by itself there? Yep.
-1.
-1. How about once x is by itself in the middle one? 1/2. Yep. And what about once x is by itself in the last one? 2. Now keep those 3 numbers in mind. -1, 1/2, and 2. Let me put the graph back up on the board. And I want you to see if you notice something. Okay, so here's my, oops, let me make it brighter. Here's my graph. Excuse me. So we had those three numbers, -1, 1/2, and 2. What do you notice about those numbers on that graph on the x-axis? -1, 1/2, and 2. Yep.
There where the line hits the x-axis.
Right. Those are the three numbers, -1, 1/2, and 2. Those are the three numbers where the graph crosses the x-axis. So if you can take something that's kind of complicated and break it down so it's different sets of parentheses, that makes it a lot easier to find those spots where it crosses the x-axis. So those numbers that we just found, -1, 1/2, and 2, those three numbers are called the roots, or the zeros of that equation. Not every equation has three of them. Some have 2, some have 1, some have none. So in our problem, we did -1, 1/2, and 2. Those are the numbers that we found for A. When you write those numbers as a coordinate, like -1, 0, 1/2, 0, 2, 0, those are called x-intercepts. So when you take the three numbers we found and write them as a coordinate with a comma and a 0, you've given me the x-intercepts. If you just write down the three numbers that I circled, not as coordinates, but just write the three numbers, those numbers are called the roots. So writing roots and writing x-intercepts is very similar. Roots and zeros are just numbers. X-intercepts are full coordinates. Okay. So any question on the difference between an x-intercept and a root or a zero? And I'm going to show you how you can find zeros on the calculator automatically in a little bit. So let's think, that's a cubic, okay, because I had a degree 3 on it. Degree 3 means the highest exponent there is a 3. I want to look at something a little simpler. Okay, degree 2 would be a quadratic. I want to go even simpler. Degree 1, that's linear, straight lines. If I draw a line on this graph that's not horizontal, anything except horizontal, how many times would it cross the x-axis?
One.
One time. No matter how you draw a line, it's only going to cross the x-axis one time. So let's see if we can find the root of a linear equation. Finding the root just means to take your equation and set it equal to 0. What would be my first step to get x by itself in that equation? Yep.
Subtract 3 from the side.
Subtract 3 from both sides. All right. And what would be my last step? Yep.
Divide by 2.
Divide by 2. Divide by 2. So we get x equals -3/2. And that's the answer to this equation when you set it equal to 0. So what do we call that number? -3/2 is the root. It's the root of the equation. Now, I'm going to show you this in more detail in a minute, but let me kind of just give you like a little preview of what's going to happen. Let's type in 2x plus 3. And I'm going to do a zoom 6. I want to calculate exactly where that line crosses the x-axis. I'm going to press second, and I'm going to press calc, and I'm going to try to calculate the 0 of this equation. When I go to calculate a 0, the calculator is going to ask me 3 things. The first thing it's going to say is left bound. That means move your cursor so it's somewhere to the left of where you think it crosses the x-axis. and hit enter. Then the next question it asks me is right bound. I'm going to move our cursor somewhere to the right of where we think it crosses the x-axis. We're going to hit enter again. What we've done now is we've given the calculator a zone to kind of look in and say somewhere between here and here, look for where it crosses the x-axis. Right, if you're using a different calculator, it might look a little different, but that's how it'll look on all of mine. So notice the last thing it asks for is a guess. The guess doesn't really matter. You can just put it, just put it kind of close to where you think it crosses, and hit enter. And if we did it right, it should give me negative 1.5. Okay? And it does. It tells me it crosses the x-axis at negative 1.5. It'll never give it to you as a fraction. It doesn't do that. But we'll practice doing that a little bit more. But any questions on how we solved that equation for 0, for its root? Okay, linear equations, hopefully from Algebra 1, you should be very comfortable getting x by itself. Right. Shouldn't really need the graphing calculator to get negative 1.5. I think the graphing calculator is probably slower than just doing the algebra. All right, so now let's step it up from a linear equation. Let's look at a quadratic. So now quadratic, it's no longer a line. It's a U shape. The highest exponent is a 2. That U shape is a parabola. How many times can a parabola cross the x-axis at most? Shelley?
2.
Yep, it can cross twice. Is it possible it just crosses once? Yep, if it just came down and just touched the axis and went back up. Is it possible it didn't cross at all? Yes. So we have a quick way to figure that out. We talked about that at the end of class yesterday. If you check what b squared minus 4ac is, it's not the whole quadratic formula, it's part of it. But if you just check that part, if it comes out less than 0, it never crosses the x-axis. If it comes out equal to 0, it just touches the axis once. And if it comes out more than 0, that means it crosses the x-axis how many times? Yep, twice. Okay, you have a chart for that, and it's the very last thing we did in the notes yesterday. Okay. So I'm not going to write that whole chart down again. So let's solve this equation and get an approximate answer. Okay, when they say approximate, that means a decimal is okay. If they asked for an exact answer, well, what's the name of the formula that you use to solve an equation where the highest exponent is a 2? We'd have to use that formula if this said exact answer. What's the name of that formula? Yep.
Quadratic.
Yep, the quadratic formula. So if the directions say solve, give the exact answer, you need quadratic formula. And when you do quadratic formula, you get something like, I'm just making this up, don't write this down. 3 plus or minus the square root of 5 over, I don't know, 7. That's what an exact answer looks like when you do quadratic formula. Right? That's not this one. Right? But that's what an exact answer would look like. It has a square root in it, and it is not rounded off. This problem says approximate. The calculator can do that. It can tell us an approximate answer. In order to type this in on the calculator and solve for the zeros, we need to get this equal to something. We don't want it equal to 2x squared. What do I want to get by itself on one side of that equation? Yeah.
X.
Well, if we were going to use the quadratic formula, that's what the formula would do. But before we even use that formula, we have to fix how this is set up. This would not be ready to do quadratic formula yet, or factor it, or even type it in on the calculator. We have to do the same first step, no matter which method we want to use. Yeah?
Set it equal to 0.
Right, we've got to get it equal to 0. This one already was. This one is not. What I would do to get it equal to 0 is move all of that to the other side, because generally I like to keep the squared term positive. Because when you learned how to factor, that's how you were taught. The squared term was always positive. Okay, so how would I move both of these to the other side? What operation would I need? Yep.
Subtraction.
Subtraction. So we're going to have 2x squared. The 1 we're going to subtract. So that's how that would move to the other side. And how would the negative 2x move to the other side? Yep.
Addition.
That we're going to have to add. So add the 2x minus the 1. Now you've got everything on one side. Let's graph it and see what happens. Okay, so let's type in 2x squared plus 2x minus 1. Again, zoom 6 isn't always going to work, but I think in this section it does. Okay. First of all, how many answers does it look like we have? Martin?
2.
Yeah, 2. It's going to cross the x-axis twice. So we're going to press second, calc, option 2, that's the 0. And you got to do each one of them one at a time. Let's start with the one on the left. Okay. Keep moving your cursor till you know for sure it's to the left of your 0. Hit enter. You should see a dotted line. Move your cursor to the right of the 0. Hit enter. You should see another dotted line. And the guess doesn't really matter. You just hit enter. And that's your first 0. Negative 1.37. Okay. How many people got negative 1.37 when they tried it? Okay. So remember, this symbol means it's about. It doesn't mean that this is the exact answer. Okay, it's approximately negative 1.37. Even if you wrote down all these decimals, that's still not the exact answer. Okay? The exact answer has an infinite amount of decimals to it. It never stops. So the only way to get the exact answer is you would need to do quadratic formula. Okay? But in this problem, an approximate answer is okay because that's what the directions said. All right, can somebody walk me through how I find my other root in this graph? What do I have to do? Yeah.
Second, and then calc,
Mm-hmm.
and then you go to 0, which is 2.
Option 2. Yep.
And then you go to the left as far as you can.
Okay, I'm to the left.
And then you hit enter.
And you hit enter, that's an important part.
And then you go to the right where you think it's far enough. And then you hit enter again.
Yeah.
And then you can just make a guess on where it is.
Yeah, the guess isn't really important, but there's my guess.
And then you hit enter.
And I hit enter. Perfect. And there's your other answer. 0.37. And that's how you find roots on a calculator if they ask for an approximate answer. Okay. If they asked for an exact answer, how would you do it on the calculator? Yep.
When you use the quadratic formula.
Exactly, you wouldn't. You do not use the calculator if they want an exact answer. It won't work. You have to use quadratic formula. Yep.
I keep getting an error every time I try to do that.
And you're picking a point left bound, right bound, and guess. Let me take a look and see. Show me what you typed in. Second calc, and then which option you need here. 2. Yep. So you go to the left. You're not to the left yet. Now you're good. Now hit enter.
There.
Now go to the right.
I do like that.
Yep, it'll work now. And then hit enter.
Oh,
There you go.
what's it?
Maybe you weren't far enough left and right before. So to find roots graphically, I'm going to reword that. So to find roots graphically, you press second, and then you press calc, and it's option 2 on my calculator. That's labeled 0. On older calculators, it might also be labeled root. But that's how you find root graphically. And then you got to do the left bound, the right bound, and the guess. Okay. Does everyone have those 2 steps for finding roots? That's something that I would not tell you on the test tomorrow. Okay, you have to know if you're like, I don't remember where the button is to find a root. No, I showed you that today, so I'm going to see if you know where the button is tomorrow. Okay, so let's try, I guess let's try this one. Is that ready to type in on the calculator? Nope, what do I have to do? Whenever we type it in and we're finding the roots, we gotta make sure it's equal to 0. Now it's ready to type in. Now we did a cubic at the beginning of class. The one we did at the beginning of class, how many times did it cross the x-axis? Crossed 3 times. Well, let's try this one. We've got x cubed plus 2x minus 1. I'm going to do zoom 6. How many times does it look like that one crosses?
Once.
Yeah, it's just once. Cubics don't necessarily have to do a full turn like that and then turn again. They can kind of just start to take a turn and be like, nope, and then just keep going. So a cubic can look just like that. So in this particular case, it does only cross 1 time. And it crosses, it looks to me like it's about 0.5. But let's figure it out with a little bit better accuracy. Pick a point to the left, pick a point to the right, and do your guess. It's close to 0.5. It's actually 0.45. 0.45. If I wrote down every number, 0.45339765, would that be an exact answer? No. There's an infinite amount of decimals in this answer. It just keeps going. But the calculator stops. I think it shows like 8 decimals, and that's all it shows on that screen. Yep.
I must be doing something wrong because I got it again.
So when you do second calc, you got to make sure, basically, when you do it left bound, make sure that that y value is definitely a negative. If it's not, you're not far enough over. Hit enter. And then if I press it right here, my y value is still negative, which means I haven't gone past the 0. So now it should be a positive. Hit enter. And then hit enter one more time, and it should say 0.45. No? Let me see. Show me one more time. Nope. You gotta go the other way. Oh, to the left. Left bound. So you want to be to the left of it. And then now go to the right of it. There you go. And then just hit enter, and now it works.
Oh, heck.
Yep. Okay. Any other questions on finding that? So that's an example of what we call a cubic, because it's the highest exponent is a 3. So cubics can have different looks to them. I kind of showed you this. Cubics can take that full turn and then another turn. Or the cubic can kind of come down, start thinking about turning, and never really do it. Cubics don't have to have every one of those terms, but they do have to have that one. If they don't have an exponent of 3, then it's not a cubic. this would be the simplest cubic you could have. Y equals x cubed. Doesn't have this, doesn't have that, and it doesn't have that. Those are all zeros. But it's still a cubic. When you start to add in these other terms, that's when it starts to make the graph look more complicated and do more of those terms. Okay, you really don't have to write down page 80, because I kind of showed you right there. So that's what they look like. All right. Any questions on that? So if on the test I gave you something like this and said, how many solutions does that equation have? When you graph it, what would you be looking for?
How many times it crosses?
How many times it crosses. Yep. And then if I asked you to find one of the places where it crosses, what do you press? Yep.
I forgot what you meant.
Yep.
Second, and then option 2 is 0.
Yep, second calc, and then the second option down is 0. So that's all I was going to practice in this one again, was graphing it and calculating a 0. We've already done it a few times, but does anybody want to see it again? Yep, so we just type it in. So clear out what's in there. X cubed minus 5x squared plus 6x minus 1. Again, zoom 6 doesn't always work, but it does in this second. So by looking at the graph, I can tell it crosses 3 times. So that answers that question. And then I think the second part was to just find one of the answers. Yeah, find the one in the middle. So by the one in the middle, I mean that one right there. So you're going to do second calc 0. Pick a point to the left, and again, if you look at your y value, when you pick one of the points, your y value should be positive because it's on one side of the 0. And the next time, it needs to be negative. If it's not, you're going to get an error. Okay. So my y value is positive. Go far enough to the right. Okay. I know I went far enough because the y value just switched to negative. So that means I went past the 0 point. And then do my guess. 1.55. That's the middle root. Any question on that? All right, so the last thing, yeah, okay. So the last thing we're going to look at, it's not much. It's really just 2 slides in this section. And we're going to save most of this section for the next time. But finding a complete graph. So keep in mind, when you are trying to find a window, when you're doing a word problem, sometimes certain values don't make sense. Like if I was selling tickets, and I said, let X be the number of tickets that I sell. What would not make sense for a number that represents tickets? This number wouldn't make any sense at all. Yeah?
A negative number?
Yeah, you shouldn't have negatives, right? That wouldn't make sense. Maybe algebraically it makes sense. You could plug in a negative. But in terms of our word problem, it doesn't make sense. So we have to keep that in mind when we're setting up a graph for one of our situations. Yep.
You can't have any fractions.
Yeah, for tickets, that also wouldn't make sense. You wouldn't plug in like 2/3 of a ticket. You either buy a ticket or you don't buy a ticket.
Same thing with decimals?
Yeah, decimals and fractions, yep. Pretty much anything you buy at a store, well, I shouldn't say anything. A lot of things you buy in stores, you either buy the item or you don't buy the item. You can't buy like half an item. I mean, sometimes you can if you're buying like a, like a piece of wood. You can buy like a shorter piece, and technically that's like half the piece. But Usually you buy the item or you don't buy it. So we're going to look at one problem in this section, and it's going to be about investing money. Now, one thing, just to make clear up front, if you only have a certain amount of money to invest, like $20,000, you can't invest more than $20,000. That's the amount of money that Bill has. So if you ever got an answer to a problem like this that said, well, I think Bill might have invested $30,000. No, he didn't. He only has $20,000. So keep that in mind. This is like an upper limit on how much money he can invest. Okay, $20,000. Okay, so that's all Bill has, $20,000. He has two different investments that he's going to put this money in. To keep the investment relatively easy for us to do, I'm going to do a problem about simple interest. Okay, so if you're familiar with like banking and the fact that like when you buy a house, you get a mortgage, you have to pay interest. It's like basically thanking the bank for letting letting you borrow money. A mandatory thank you. And then when you put your money in a bank account, the bank thanks you a little bit by giving you interest. The way that the bank would do interest is not what I'm going to show in this problem. They would use a little bit more complicated formula. Okay, we're going to use what's called simple interest. So Bill has two investments he can pick from. One investment pays 6.75%. The other investment pays 8.6%. And the formula that you need for a simple interest problem is I equals PRT. That's the simple interest formula. I equals PRT. I is interest. In this case, it'll represent the amount of money that Bill is going to make by putting his investment in the bank. Principal is that's the amount of money that you invest. R is the rate. What's very important though is when you use the rate, it has to be a decimal. So something like 12% has to be changed to 0.12. The easy way to change percent to a decimal is you just divide it by 100. Or move the decimal 2 places to the left. That's what dividing by 100 does. And T is the time. That's the amount of time you're going to leave your money in the bank. 1 year, 10 years. The longer you leave it, the more money you make. So we don't know how Bill's going to split up his money. But he's got $20,000. He's going to invest all of it. He's going to put some of the money here in that investment. He's going to put the rest of the money there. But we don't know the split. Could be equal, 10,000, 10,000. Maybe he'll do 15,000 and 5. We don't know. Since we don't know, let's let X be the amount of money that he puts in the first investment, 6.75%. Using that variable, so X is going to be the variable, I want to find an equation that represents the amount of total interest that he earns in 1 year. Okay, so the first thing we want to remember is how many different investments is Bill going to split his money up into? Yeah, two. Okay, he's going to split his money into 2 investments. So what we want to do is find the interest he earns in the first investment, then find the interest he earns in the second investment, and then we'll find the total. So let's start with the first investment, 6.75%. I want to find the interest that he earns in that investment. So it's I equals PRT. The principal is how much money you put in the investment. How much money did Bill put in the 6.75% investment? Yeah.
We don't know.
We don't know exactly how much money, but we do have a way to represent it. Yeah?
X.
He put X. X dollars was invested at the 6.75%. So that's my principal. What would my rate be? And just remember, the rate has to be a decimal. Yeah?
Would it be the 6.75?
And what would you put in right there exactly?
0.0675.
Yes, 0.0675. And the last thing is the time. How long is Bill leaving his money in the bank in this problem? 1 year. It says find the interest earned in 1 year. So technically multiplying by 1, it doesn't do anything. Okay, so let's multiply that out, and let's write it how we normally would write something. That's 0.0675 times x times 1. Okay. So that formula, if you tell me how much money he invests in the 6.75% account, I can fill it in for x, and I'll tell you how much money he'll make. Okay. Any question on how we got the interest for the first account? Okay, now let's do the interest for the second one. I equals PRT again. We already have invested X dollars out of the 20,000 in the first account. How much money is left for the second account? Yep.
20,000 minus X.
Yep, exactly. Do not pick a different letter. There's no need to. If he invests $1,000 in the first account, there's 20,000 minus 1,000 in the second. Just subtract what you already invested from your total. Okay, what's the rate as a decimal going to be in this one? Yep.
0.086.
0.086. And again, this part doesn't matter in this particular problem, but the time he's doing the investment for is, yeah, 1 year. Okay, so when we clean this one up, we got a little bit more work to do. We have to distribute that. Is there any question why that's a distributive property? Okay. Well, I know it's going to be negative 0.086 x, but I need 0.086 times 20,000. Is that 1720? Yep. Okay. So that's the amount of interest that Bill's going to earn in the second investment. All right. So we got how much interest from the first one, how much interest from the second one. Now I want to know the total he makes. Well, I already have how much money he makes separately in each one. So what would I do with them to find the total that he makes? Yeah.
Add them together.
Add them together. So we're going to add them up, and we're going to combine like terms. So what I need to do is negative 0.086 plus 0.0675. I need to know what those two things add up to. The plus 1720, there's nothing to combine it with, so I'll just copy that down. Yep.
It's negative 0.0185.
Negative 0.0185. Okay, so that is box 1 plus box 2. That's box 1, that's box 2. Okay, now they're going to ask us to do something with that equation in a second, but for now, that's all they want. Find an algebraic representation for the interest earned in 1 year. Okay. Okay. Any question on getting that? That's the the hardest part of the whole problem. Okay, so we're going to graph it. And keep in mind, once we graph it, there is a difference between how this would graph, thinking about it algebraically, and how we should graph it in terms of our specific problem. We're dealing with money. What values don't make sense for, let's say, the money invested in this problem? Bill could not invest what kind of amounts of money? Yeah?
Negative.
Yeah, I can't invest negatives. So when we start to set up our window, X is the amount of money that's invested. We shouldn't be looking at investing negative amounts of money. Is there a maximum amount of money we have to invest?
Yes.
Well, if not, then Bill has unlimited money. He doesn't have to worry about investing at all. Yeah?
20,000.
20,000. He doesn't have more than 20,000. So we shouldn't be looking any higher than that. Now, Bill's going to be making money on the interest. So if he's making money, is he going to lose $10? No. This is not an investment where you can lose money. A lot of investments are, but this one's not. Okay? So there's no reason to be looking at negatives. And let's think about what's going to happen when we graph these equations. What's the y-intercept in equation 2? Or the y-intercept in the total interest formula? Doesn't matter. Yeah?
1720.
1720. So when we start typing this in, this total interest formula, we're going to have a y-intercept of 1720 and a slope of negative 0.01. Since the slope is negative, what direction does that mean the line is going to slant in as you go to the right? It's going to slant down. So I don't need to look any higher than 1720 because it's not going to go up. It's going to slant down. Now, so I don't have my y max right on the edge. I might do like 1800. Okay, so we got our window set up. So let's type that equation in. We don't even know what they're going to ask us yet, but it's going to be something with the total interest. So we should just get that formula ready. Negative 0.0185x plus 1720. And when we graph it, we should see a line starting at 1720 and going down slowly. Okay, so that line represents the different possible amounts of money Bill could earn depending on how much he puts in each investment. Each point on that line is a different amount of money he could make. Okay, I did that. All right, so now it basically wants to know, how did Bill split up his money? This is how much interest he earned. $1,509.10. In order to earn that amount of interest, he would have had to put some of his money in the first account and some in the second. I want to know exactly how much. Okay, so look at your formula for total interest. That $1,509.10, it has to be plugged in somewhere in the total interest formula. Where would that 1,509 get plugged in? There's two places you could plug it in. Yeah?
Looking for I.
Yeah, you're going to plug it in for that I, for the interest. So you're going to plug it in right there. Okay. So what we're going to do, let's plug that in. And what I'm going to do is to plug that in is I'm just going to type it in Y2. When I type something in Y2 and it's just a number, Y equals, and you have a number, what kind of line is that? There's no X in this second one. Yeah?
Horizontal?
It's going to be a perfectly horizontal line. The answer that I'm looking for to that question is on the screen. Where do you think I need to look to find the answer? Yeah?
At the intersection?
Right, at the intersection. And I think we've done intersections before, right? Yeah. So second calc, option 5, not option 2. I know we were using that earlier. But option 5 is where they intersect. You pick a point anywhere on the blue. It's going to ask you 3 questions, just like the other one. Pick a point anywhere on the red, and then do your guess. Just put your guess kind of close. Okay. And I have the exact intersection point. Okay, so let's look at that. So it is telling me that x is 11,400. If you don't remember what x is, scroll back up. What was x in this problem? Yeah,
The amount of money invested.
can you be more specific? Principal in, we need more information. Yeah?
What do you invest into the first account?
And the first account was which interest rate?
It was the 6.75.
Yes. X is the amount of money that Bill put in the 6.75% account. So we know that number now. It's 11,400. Okay, so in the 6.75% account, we got $11,400 invested. Still need to figure out the 8.6%. How can I figure out how much money he put in that account? Yeah.
Couldn't you just do 20,000 minus the?
Yeah. He's going to invest all the money. So if you put 11,400 in the first one, whatever's left goes in the second one, and that would be 8,600. So these kind of interest problems are exactly the same setup every time. The only thing that's different is the amount of money you have, the interest rates, and the amount of interest that you earned. But other than those numbers, you just plug them in and do the same thing every time with this problem. Any questions on that? All right. So let me put up the homework, and I'm going to put up a list of test topics. I'm probably not going to get that done before you leave, though, but it will be in the paper. Let me.
Could you post the test topics on Schoology or something?
They're definitely going to be on YouTube.
Okay.
And you could like screenshot it, but yeah, it'll definitely be on YouTube. I'll see what else I can do. Yeah. Do you have access to YouTube? Yeah. Okay. All right. Let me just double check. 1 through 5. That's just going to be odd. So just 1, 3, and 5. 9. Yeah. Let's just cut out number 10. So 9, 11. Okay. 7. Let me just check the 8. Okay, yep, so that's good. 31 to 34, that's an interest problem. I equals PRT, so all the same question. 21 to 23, that's a rectangle problem, kind of like the one we did at the beginning of class in the homework. And 5 through 12 is, actually it's all rectangle problems. So these are all rectangle questions. All right, so we'll look at that tomorrow, and I'll put up a list of test topics. I'll start now, but I'll finish it while you guys are at lunch.